there, and welcome to lesson 3 on our science learning about light. In fact, I'm going to take lesson 3 and lesson 4 and kind of squish them together because you've already done some of lesson 4 when you did your experiments with sundials. Wanted to do that while it was really sunny. So today what we're focusing on is thinking about how, because light travels in straight lines, it affects the way that shadows behave. By now you should understand that we would say that a shadow is an absence of light. It's where the light can't get to, and it can't get there because it can't travel around corners. So if this is my opaque object and my light source is over here, then shining the light there, the light will hit this, and some of it will go on the sides, but where this is blocked, there's going to be no light. At least if there's a single source of light, there'll be no light. And that's where the shadow will form. Okay, makes sense. So today, what you're going to be doing is thinking about the shape and size of the shadow that's formed by that opaque object. All right, and thinking about what difference it makes where the object is compared to the light source and compared to where the shadow forms. All right, so the different positions of those three things: the light source, the object, and the place where the shadow falls. So you're going to make a little screen to go behind it. We're going to look at what difference that makes. Now, this is an experiment that we would have done in school. It's quite a nice one because it's really helps you to understand how shadows are formed and therefore how light works. But also it'll result in a nice graph. You're going to do mu graph. And just to start off with, I'm just going to show you what that graph might look like. See here? So you're going to create a graph, something like that. And you can always skip to the end and have a little look if that helps. So how are you going to do that? Well, first of all, we are going to, so this first slide here, this is just talking about what I've just talked about, and about light travelling in straight lines and the objects blocking the path. And there's quite a nice little clip here if you want to watch that. But here's the actual investigation that you're going to do. It says 20 to 30 minutes. I'm thinking probably more like 30 because you're also going to do the graph, and you'll do it really nicely, and you'll use a ruler and everything. It's going to be fantastic. So first of all, talk to parents about this before you do it, but we want a blank piece of paper stuck on the wall. Do be careful because sometimes the blue tack or sellotape can leave a mark when you take it off. So talk to people at home about where's the best place to do that. And then you're going to take a bottle, like in this picture here, and put a fork in the top. That is simply so that you can get the fork to stand up. The fork is going to be your opaque object that is blocking the light. It could be something else. It could be a spoon. Maybe you've got something already that will stand up, like a little block of wood. It's not really important. The bottle is only there to help it stand up. Okay? Then you're going to put that 20 centimetres from the wall. You've got the wall here, measure 20 centimetres, and then you're going to put your object, your fork. And you're going to put a torch. A torch on a phone is particularly good because they're really bright. And you're going to fix that at the same height as your fork. Okay. Make the room as dark as possible. That's another thing to talk to people at home about. Which room could you make most dark, because it'll be easiest to do when it's dark. And you're going to start with your torch 80 centimetres away. So you've got a metre. You've got 80 centimetres to your object for your torch, and then you've got 20 centimetres from that. And you're going to draw the length of the fork, or the width of the fork, or the length of the prong. It doesn't really matter as long as you do it the same every time. So something that shows the size and location of the shadow on that piece of paper. Then you're going to move your torch 10 centimetres closer, so now it's going to be 70. And you're going to do the same again. Measure the length of the fork shadow, and then again and again and again. So then you'll record the size of the shadows on your graph. So here, this shows what you're recording each time, what's the size of the shadow, and as long as you're measuring the same part of the fork each time, whether it's the width, the length of the prongs bit, or just one of those little prongs are called tines, so that little tine, it doesn't matter as long as that's the same. So those are going to go in there, and the distance between the fork and the torch is what you're going to measure down here. Makes sense? And this one, the first one's going to be 80 in there, and that will be whatever it is. I can't tell that because I don't know what the length of your fork is. All right. Then you're going to plot it in here. So up here is going to go the size of the shadow, and across here is going to go the distance from your torch to your object. So let's say, for example, you've got the first one is 80, let's imagine, and the size of the shadow is, I'm going to say, 30 millimeters. Don't have to put the units in because it's got it up there, look, millimeters. So then I'd be going 10, 20, 30, 40, 50, 60, 70, 80, and then I would label this 10, 20, 30, etc. So then I'd be going 80, 30, and I put my little cross there, and then move on to the next measurement. All right, we've done that before, so with any luck, you'll be comfortable with that. That is what I'd like you to send me. I want to see your graph. I'm quite happy to see this as well, but it's the graph that I'd really like to see with this bit filled in. If it's easier, just write it on a separate piece of paper. If you prefer to do your graph on a different piece of paper, that's fine, or you can print this out, whatever works for you. All right, so you're then going to draw your line of best fit. Do you remember how to do that? So you're looking at drawing a line that goes as close as possible to as many of those little crosses as possible. Now, we've done that before with where it's a straight line, but this one may not be. All right. Now then, right at the end, there are some really nice little shadow theatre films to watch. I find them fascinating. And there's one here with a question that I'd like you to answer. Thinking about, it says, think or talk about how you'd explain to one of the judges how in the last scene, two dancers of about the same height can appear as a small girl and her much larger mother. So I'd really like you to explain that to me. You can just message me with that explanation, or you can write it down and photograph it. I don't mind. There's your glossary, and there's an example of what it might look like. Oh, sorry about that. Messages coming in. Yeah, if you get stuck, have a look at that. All right, so now that's the end of lesson 3. But as I said, I'm just going to put lesson 4 in this as well because you've already done most of this. So it's not really a whole lesson on its own. So what have we got? What we're looking at here is the sun as a source of light and how that affects shadows on Earth and how that means we can tell the time of day. Now, you've already done half of this because you did that really nice sundial experiment where you measured the distance between the shadows. This one, similar in that you're going to put something outside, you're going to measure something at different intervals during the day, but what you're measuring is different. All right, so let's have a look. What are you going to do? So starting in the morning, you've got to have a sunny day. With any luck, we'll have another sunny day soon. It's pretty grey outside for me today, but who knows? And you're going to use a bottle or similar as your object. And what it suggests is that underneath your object you mark, if you've got some chalk or something like that, mark a little on the where it's standing so that when you take it away you can see where it was, because you've got to measure from where that was standing to the little marks you make. All right. So we're going to mark across under it. Here it says start under bottle. And what you're going to do then is make you're going to, where you can see where the shadow is there, and you make a little cross at 3 o'clock or whatever it is at the end of the shadow. So we're measuring the length of the shadow, not the distance in between them. Okay. So then again, at the end of the day, you're going to measure all those distances, the distance between where the bottle was and each of your crosses, which you've done every hour or every half hour during the day. Once again, just like the last one, you've got a grid here. Oh look, it's even got a set of false results that you can use if it isn't sunny. So I hope you can find a sunny day, but if not, you can use that and still make your graph. All right. I'm going to say that one's optional, but it'd be ever so nice if you would do it. I'm saying it's optional because you have done something quite similar, and you will have already done me a graph. But I'd really like you to do it, partly because practicing doing the graphs is good, and if you do two quite close together, that's going to help it stick in your head and really secure that learning. But also because it is slightly different, it's quite interesting to look at how the length of the shadows changes. So again, I'm going to put this PowerPoint up in the files, and again, there's an example graph there for you to use if you get stuck. So a recap. I'm going to put my little list over here for my other monitor. So I've already talked you through what you're going to do in lesson 1 and lesson 2. So in lesson 3 and 4 that I've just talked to you about, you are going to do the experiment with the fork and the light source and the piece of paper on the wall. You're going to record your results, and you're going to create a graph with a line of best fits. Okay, that's your main activity for lesson 3. You're then going to watch 1 or 2 of the shadow videos, and you're going to tell me how it is that the 2 dancers can appear to be such different heights when actually they're similar heights. Talk to me about the position of people and the light source. It's going to be quite interesting to see if you've really understood the learning from doing the experiment with the fork. All right, so that's lesson 3. And then lesson 4, optional, investigate how shadows change throughout the day. That's the one with the bottle outside and measuring the length of the shadows from that bottle, creating the graph. Okay. So I really hope that you'll enjoy doing those activities. I think you seem to have enjoyed doing the science activities so far, so with any luck you will. I'll finish this now, and then you've got 1 more video which is explaining what I want you to do with the whole project, because I would like you to do a fantastic piece of writing, which I'll tell you about in a separate video. Okay, over for now.